So, for example 9, it says the Citibank pays a simple interest at 3% per year, meaning that the balance increases by 3% after they've deposited their initial. National Bank is a compounded interest of 2.6 per year, but that's compounded monthly. So, meaning that each month that balance is increased by that 1.6%. So when I'm looking at this, we're looking at two different scenarios here. We're looking at the Citibank, that's just a basic increase of 3% every year. And we're looking at the National Bank, which is 2.6%, but is compounded monthly. So in the first question, it says, which bank provides the largest balance if you pay an investment of $10,000 for 10 years or for 15 years? So ultimately what we need to do is we need to figure out the equations for both of them. We can't answer that question until we've answered them. So when I'm thinking about the Citibank was just a basic 3%. So the 3%, that's going to be divided by 100. So my rate is going to turn into 0.03. And it is increasing. So we're going to use our growth formula. Our growth formula is A equals 1 plus R raised to T, which is our time. So we have Y equals an initial amount of 3%. And let me write this in the correct spot. Oops. All right, there we go. So we have 3%, and we have 1 plus our rate, which is 0.03. And we're going to raise that to X. That's our time. So the formula here is 300 times 1.03 raised to X, which means it's increasing because it's greater than 1 for my base. All right, for the National Bank, we got to do monthly. Now, monthly, if you go back to our compound, is this formula here. So it's very similar. This is your initial amount. This is still your 1 plus your rate. The only difference is you have to use that N for your compound. So monthly is 12 times per year. So for this particular example, we're going to do N is equal to 12. If it were yearly, you would do 1. If you were quarterly, that's 4 times a year. Daily is 365. Weekly is 52 weeks in a year. Everything compares back to a year. All right, so I have Y equals, and my initial amount is still going to be 300. This is going to be 1 plus my rate. So my rate for the National Bank was 2.6% divided by 100, which is going to be 0.26. And I actually forgot a 0 there. So 0.026. So 0.026. But that rate has to be divided by my compound, which is 12. And then that's going to be 12 raised to X, which is my time. Now, the problem itself asked me to compare 10 years and 15 years. Okay? So we're going to use both of these formulas. We're going to use this formula for the Citibank, and we're going to use this formula for the National Bank, and we're going to compare 10 and 15. Okay? So I'm just going to plug it directly in and kind of look at it. So I have 300 times 1.03, and we're raising that to 10 years. All right. Now, we also have our National Bank. So remember, the National Bank was 300 times 1 plus, and I'm going to hit that division sign to go ahead and put the fraction in. This is 0.026 divided by 12. And we're going to raise that to 12x. And my time is 10 years. Bank is actually going to be a better option because we actually gained more money over that 10-year time frame. All right, so in the original problem, it's actually asking us to compare 10,000. So I did it originally with the 300. But it says, which bank would provide the largest balance if you plan to invest $10,000? So we're going to change that $10,000 and make that our initial value. So we're going to change that to 10,000. And we're going to change that to 10,000. So if I'm looking at my Citibank, even though it wasn't compounded every month, it still was a better deal because of the fact that it had 3%, and my National Bank, it was compounded monthly, which you would necessarily get a higher amount if it was compounded monthly if it was the same percentage. So the percentage was lower for the National Bank, and it was still compounded monthly, so it gave me a little bit less over the 10-year time frame. So I could also adjust that, and then it says to compare it to 15. So if I compare that to 15, we can still see that it's a little bit less because the percentage is less as far as the comparison. Now, if I made this 3% like the other one, that it's going to be a little bit more. So you actually get a little bit more money when you compare just a regular yearly compound versus a monthly compound, as long as it's the same percentage. All right, so then we have, it asked me to really do some comparisons between the two of them. Again, that we kind of just talked through that. The Citibank is going to be better because the percentage is higher. If the percentages were equal, then the National Bank would have been better because it's compounded monthly. And you're getting just a little bit more added on every month than you did the previous month. All right, so a half-life. So a half-life, when you're talking about that, obviously you're splitting it in half, but you've got to make sure you account for the fact of how long it takes that amount to split in half. So it says write an exponential decay function for 24 milligrams. So it says in this problem I have carbon-14, and it's got a half-life of 5,730 years. That's how long it takes to split in half. So my initial value of carbon-14 is going to be 24, because that's what they told me in the problem. And then it says that we have a half-life, so we know my base has to be half. Now here's where this is going to make the difference. So my time is still going to be x, but I'm going to divide that time by 5,730 years, because that is how long it took it to split in half. When you're doing half-lives, you always got to account for the fact of how long it takes to split, okay? So if I ask you for the next one, it says how much would carbon-14 how much would remain after 30 millennia? Well, 30 millennia is 1,000 years. So we're actually talking about 30,000 years. Okay? So if I could put this in Desmos, I should be able to see that I have 24 and I have 1/2. And I'm going to raise that to 30,000. But that 30,000 has to be divided by 5,730. All right, so when I look at that, I have exactly 0.6. So I have approximately 0.64 of the carbon-14 left. Okay. All right, so for the next one, it says that we have this thallium-201. It has a half-life of 73 hours. So that's how much it takes to split. If 4 milligrams of the thallium-201 disintegrates over a period of 6 days and 2 hours, how much of that will remain? Now, when I'm looking at this, I see that I initially have 4 milligrams. I have a half-life, and my time is going to take 73 hours to split. Now, it says that it disintegrated in 6 days and 2 hours. Well, we are talking about hours in this problem, okay? So if I convert 6 days and 2 hours, that's going to convert to, well, there's 24 hours in a day, right? So 6 times 24. So we have 144 plus two extra hours. We have 146 hours. So I can take that 146 hours and I can plug that in for X. And I can go right into my problem. So I have started with 4. I'm going to half-life it. And I'm going to raise that to 146. And we're going to divide that by 73. It took it 73 hours to half. And I see that it actually is going to have approximately 1 milligram left after that time frame. I hope this helps.